Reconstitution of Non-Injectable Solutions. So I'll let you take the time to pause this video to read the information. I'm going to just go over it without reading it all to you. Let's talk about this here, these pictures here. I like to use an example of concentrated grape juice you can buy in the freezer, or Kool-Aid that you can buy that's powder form. You got to mix it, or tea. A lot of people likes tea. So what we have here is a solute. The solute would be the concentration. That would be my tea bag in that hot water, right? You wouldn't just drink that. You were going to add, well, some people may drink hot tea, but most people will add water to it. Grape juice that you buy out of the freezer, it's frozen. You got to add water to it to drink it. Lemonade powder, when you put it in your water, you can mix it up and drink it. So the solute is the actual substance, right? The solvent here is the water that you're going to use to dilute it down to make it drinkable. So depending on how strong you want it or how weak you want it, depends on how much water you're going to add. And then you have the solution. The solution is the final product. It's what you're going to drink. But in medication, we are going to be talking about specific powder form drugs, or it may be liquid form. Some diabetic medicine has to be reconstituted, right? It has to be diluted down. So I'm not going to get sciencey with it. I'm just going to keep it at a level that we all understand. But let's do this example. So this example says I have 1/4 strength reconstituted 7-ounce orange juice made from canned frozen concentration. I know that some people in the hospital has to be fed through a feeding tube, so we could be talking about ensure that they put through the tube, and you got to dilute it with water in order for it to go. So there's different ways, or different items that we could be using here as an example. Let's just talk about this fraction for just a minute. This fraction is talking about a part, right? It's telling you how strong you want it. You want it 1/4 strong. Well, what does it mean? The numerator, the top number, which is 1 in this case here, is going to be the 1 part solute. The denominator is the total solution, which makes sense. So you want to know how much water you're going to add? You take the denominator minus the numerator, and we know we're going to add, 3-part solution, or excuse me, solvent. My apologies, I kind of got off there. But anyways, so you get the point. That's what that means. We're not going to use this, though, as an answer to solving for a solute and solvent solution. Another thing is this here could have stated at the end, it could say every 6 hours, or it could say over, so let's say every 6 hours, or it could say over 6 hours. So this has a different meaning. If we're going to take that 1/4 strength of this orange juice, which is 7 ounces, that we're going to use, if we're going to take it and spread it out over 6 hours, that's just one feeding, right? So this is one feeding. However, if we're going to do it every 6 hours, well, in a 24-hour period, this would be 4 feedings. So this is very important that you understand the last part that's worded here. I'm going to work both examples, okay? So let's figure out, what is our solution? That's going to be the easiest one to figure out. Well, our solution, our total solution is the 7-ounce orange juice. So that's my total solution. We want 7 ounces of orange juice. However, my final answer cannot be in ounces. It has to be in milliliters. On this particular type of problems, always milliliters. So what I'm going to do is I'm going to take that 7 ounce and I'm going to convert it to milliliters. Well, I know for every 1 ounce, it's 30 milliliters. The ounces reduce, leave me with 7 times 30, which is 210 milliliters. Now this is good for when it is over 6 hours because it's only one feeding. But what if we are looking at every 6 hours? Then let me split the page right here in half. we're going to take that 210 milliliters and we're going to multiply that to the 4 feedings. Let me erase that. That's terrible writing. There we go. So now I have 210 times that 4, right? And that's going to tell me a total of 840 milliliters. So see the difference? The other one is just 1 feeding. We're spreading it out over a period of time. This other one is 4 feedings. We're going to do it every 6 hours. All right, let's figure out what is our solute. All right, our solute is going to be this strength here. So it's going to be the strength, which in this case is 1/4, times our solution, which is, if we're going to talk about, let's talk about this one first. It's going to be 210 milliliters. So basically, I'm going to say 210 times 1 divided by 4. And that gives me 52.5 milliliters. So in this case here, when I go get the concentrated orange juice from the freezer, I want 52.5 milliliters because I want it that strong. And I'm fixing to tell you how much water we're going to add. Now, if it's 4 feedings, now that's different. We're going to take that 1/4 times it to the 840. So what happens? We have 1 times the 840 divided by 4. That gives me 210 milliliters for my solute. Let's figure out how much water we need. So my solvent is, it's going to be my solution minus my solute. My solution is 110, or excuse me, my apologies, 210 milliliters minus that 52.5 milliliters. And that gives me a total of 157.5 milliliters. So that's how much water we want. We want 157.5 milliliters. And we're going to have of water. And we're going to have 52.5 milliliters of solute of the orange juice. We're going to mix it together to give me a grand total of 210 milliliters. That's over a period of time. Now, however, if I wanted to know over here for the 4 feedings, well, then that means I got the 840 milliliters minus the 210 milliliters, right? And now the 840 milliliters minus the 210 is 630 milliliters of water. This makes sense, right? Because if we want 1/4 strength, then we want, it's not going to be a very strong drink, right? If it was 3/4 strength, it would be a real strong drink. So just ask yourself, does it make sense? And what are we solving for here?